7th unit of ours, that is the ray optics. So the first topic which we are going to discuss in this, that is the refraction of light. So what you understand by this word refraction? So if common terms we are going to say, so what is refraction is the bending of light is known as refraction of light. If we talk about here that the refraction is the phenomena of change in the path of the light as it travels from one medium to another medium, or when the ray is light is incidentally obliquely. That is called the refraction. If when the ray travels from one medium to the another medium, we found that there is a change in its speed, and because of that we found that the ray appears to be bent to us. So there are two laws of refraction. The first law says that is the incident ray, the normal to the refracting surface at the point of incidence, and the refracted ray all lie in the same plane. So here if you will see, we have two types of medium, rarer medium and a denser medium. So what is rarer medium if I will say? So the rarer medium is defined as the medium which is optically rarer, where the molecules are far apart from each other. That is rarer medium. And what is denser medium? When the molecules are compact or very close to each other. So that is where the first law says, that is all lie in the same plane. Second law is also called the Snail's law. What is that? That says that for a given pair of a media, for the light of a given wavelength, of the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant, right? What does it mean? You already know that with the help of the refractive index we are finding the speed of light in one medium with respect to the another medium. If suppose we are going to find if we have a one given medium through which the light is traveling from one medium to another medium, then we can find out its refractive index, and that will always remains constant. That only the Snail's law states, that is sine of the angle of incidence and the sine of the angle of refraction is equals to constant. Here if we are going to discuss, we can find that is some tips are given. What are some tips? That is mu of the optically rarer medium is lower, and that for the denser medium is higher. What does it mean? Here it means that the refractive index for an optically rarer medium is always lower, and if we are going to find out the refractive index for the denser medium, it will be high. Second point, the refractive index of the denser medium with respect to the rarer medium is more than 1, and the rarer medium with respect to the denser medium is less than 1. This you have to remember, okay, that the mu value will be greater than 1 if the light travels from denser to rarer, and if it is traveling from rarer to denser, then it will be less than 1. In refraction, the velocity and the wavelength of the light change. When the refraction is taking place, we have already discussed that its speeds and its wavelength is got change, okay. In refraction, the frequency and the phase of the light does not change. It does not affect any of its frequency and its phase, okay. This is the ratio which they have given, that is a refractive index of air in with respect to a medium. So that is called an absolute refractive index, right? So this is the formula which we have. Now here we are going to discuss about the principle of reversibility. What is the principle of reversibility of the light? Here if you will see, first I will read it for you and then I will discuss this too. If a ray of light after suffering any number of reflections or refraction has its path reversed at any stage, it travels back to the source along the same path in the opposite direction. That is called the reversibility. Here if you will see, we have the refractive index of one medium with respect to the another medium. So we have find out that the reversibility will be what? Because when we find out the means, if suppose we are traveling from a rarer to a denser medium, so we found that the refractive index will be sin I upon sin r. Now suppose we are traveling from denser to the rarer medium. Here we have that is from B to A and from A to B. So what we are going to find? We are going to find sin r upon sin I, because where the refracted ray is means after refraction where it is reaching, now the from refracted ray it is Sending means the incident ray from the denser to the rarer, and the first case from the rarer to the denser. So this phenomena of occurring the light from one medium to another, or from changing its state from the second to the first, that is called the principle of reversibility. The natural consequences of the principle of reversibility is that the image and the object position can be interchanged, and these positions are called the conjugate positions. This we are going to utilize, and this we are going to discuss in a coming classes in a more detailed manner. Okay, now next we are going to talk about here refraction through a parallel slab. Suppose if we have a glass slab which is simply made up of like a prism, means it is made up of silica or a plastic or a glass. So when we are going to find out, so we are going to find when we have a thin or a thick slab we are going to take, and when we are going to put a, or we when we allow a light to pass through it, so what will happen? First, the light is traveling from a rarer to denser, so it will move away from the normal. And when the light is traveling from a denser to a rarer medium, obviously it will be moved away from the normal. And in the first case, understand, first case the light is traveling from rarer to denser medium, so you can find out the light is traveling towards the normal, r1 is traveling towards the normal. But when the light is traveling from denser to rarer, it will move away from the normal. So it we found that the ray which has to travel in a straight path, it get deviated from its actual path with some angle, and that is called the angle of deviation. And the distance between the incident ray and the refracted ray is called the lateral shift, and the ray which comes out from this is called a emergent ray. So this is the mathematical expression which we have for our refraction through a parallel slab. So these are the condition for a parallel slab. So I hope this is the introduction part only which we have discussed today. So the next class we are going to discuss everything in detail. Thank you.